Creating a car animation has always been a challenge, but in this tutorial, I tried to simplify this complex process for you as simply as possible. Hello. In this tutorial, I will teach you how to create an animation for a car from rigging to adding wheel suspension ability from A to Z. Before we start, if you're interested in this content, give us a thumbs up, hit subscribe, and join our newsletter for exclusive educational tips and updates. Stay tuned for more exciting videos. To do this, I should first rig the car in Blender. Any 3D software can do this, but we want to use the UE4 Vehicle Rigging add-on for Blender plugin, which has made things very simple. The download link is in the description. Don't worry if you are not familiar with Blender, because I will explain it very simply. Download it from the direct link. To activate it, go to the Edit section, Preferences, and from Add-on branch, click on Install and select the plugin zip file. Tick the checkbox to activate it and close Preferences. Now, by pressing the N key and selecting the plugin from the right side, we can see the plugin. By going to File section, Import, FBX, I import my car. Thank you to the maker of this car for creating it. I downloaded it from Sketchfab. You can rotate inside the page with the middle mouse drag and pan by holding down Shift plus middle mouse drag and zoom with scroll. Make sure the front of the car faces positive X. Alright, in this tutorial, I want to teach you two methods of using this plugin so that later you can rig your car however you want. The first method, which is the default method of this plugin, is for when you want only the wheels of your car to move and need a simple rig. In this case, the car should be made up of 5 parts, like the car I just imported, which consists of a body and 4 wheels. As you can see, the plugin has assigned 5 parts for us to choose from. With the Picker tool, I select the body for the vehicle base section and choose the wheels in the order they are written. Front right, rear right, front left, and rear left. Now we need to rig, but the rig button is inactive. The reason is that we need to fix the unit scale of Blender. But don't worry, this plugin has given us a button for this. Press Set Unit Scale. As you can see, the car changes size. To return it to its correct state, press Upscale Objects to return the car to its original size. Now that the vehicle rig is active, I click on it. This is the rig. I press Ctrl plus Z to change the size of the bones. I set it to half and press Rig again. It looks better now. Our simple rig is done. If this is enough for you, proceed to the export part of the video and continue from there. Now let's make it a bit more complex. What if we want the car doors to open and close? How do we rig the steering wheel? How do the calipers stay stable? Once you learn these techniques, you can rig all parts of the car. This model that you see is the same as the previous model with a series of changes. For example, if you look carefully, the doors are separated from the body, and if I zoom in a little, you can see that the caliper is also separated from the wheel, so we have more components for our car. One of the features we want to be considered in our rig is that the body should be able to move separately to show the suspension mode. In our simple rig, the body had no other subcomponents. That's why it was chosen as root. But here, the doors are connected to the body, so we need to have another root. You will understand the importance of this more in Unreal. From Add and Mesh section, I create a cube and scale its size down using the Scale tool. Now, with the help of the Move tool, I place it somewhere it won't be very visible. This is our new root. Now let's rig them. I press N and go to my plugin. Because our components are more than 5, we don't want the default mode. So I press N-wheeled vehicle. This part is for selecting our new root, which is the cube, so I select it with Picker. The Add Wheel section is useful for adding wheels or even other components. For instance, add 2 for a bicycle or tricycle, and so on. We use this feature to add cars components. Note that these components must be separate and not part of the car mesh. I will explain another method for components attached to the body, like the steering wheel. Now, for each part that we want, we press Add Wheel once. For instance, for the car body, 4 wheels, 4 calipers, and 2 doors, which ultimately 11 wheels have been added. Now we rename them. Make sure the bone name is not the same as the name of that part of the car, so that you don't run into issues during import in Unreal. I name them as follows: Body B, where B stands for bone, front right wheel B, rear right wheel B, front left wheel B, rear left wheel B. For the calipers, I add FR for front right and a C for caliper, and write the rest in a similar way as the wheels. Finally, I add right door B and left door B. Note that if you want to use the control rig that I create in Unreal later, your bone names should be like mine. Now with Picker, I select the parts that I named on the car model. As I mentioned before, the rig button is inactive, so first I need to click on Set Unit Scale and then click on Upscale Objects to return the car to its original scale. I adjust the bone sizes to half and finally rig it. Now we need to adjust the placement of some bones so they function correctly. For example, take a look at the door bone. The calipers should also rotate around their own wheel axis. Let's fix them. Select one of the bones and go into Edit mode. We are going to use the cursor tool to set the new location of our bone. First, I select the wheel bone, right-click on it, and from the Snap section, I click on Cursor to active. The cursor moves to the center of the wheel bone. Now I right-click on the caliper bone, and from the Snap section, I click on Selection to Cursor. This way, the caliper bone is moved to the center of the wheel bone. The other wheels follow the same process. Right-click on the wheel bone, snap and cursor to active. Then right-click on the caliper bone, snap and click on Selection to Cursor. I will show you the rest quickly as it involves repetitive steps. To test it out, you should switch to Pose mode. Select one of the caliper bones and rotate it. Excellent. To fix the door rotation position, once again, by selecting one of the bones, I go to the Edit mode. This time, I manually adjust the cursor position by selecting the cursor tool and clicking on the correct rotation point on the car. I return to the selection mode, right-click on the bone, and from the Snap section, I click on Selection to Cursor. I repeat this process for the left door as well. I test them in Pose mode. Now we need to fix the parenting bones. As you can see, if I rotate the body, the doors do not rotate with it, and similarly, the calipers are not connected to the wheels. To do this, when one of your bones is selected, go to Edit mode. Now select the door bone, go to the Bones section, and from Relations, change Parent to Body. Do the same for the left door. Now from Outliner, I select calipers and put their parentings on their respective wheels using the same method. For example, connect front right caliper to front right wheel, and in the same way, I make the parenting of the rest of the calipers. Now, if you look at our outliner, you will see that our outliner is also more organized. So far, everything is great. What if one of the parts we want to rig is a part of the body, like a steering wheel or windshield wipers? I hide the left door from outliner to see the steering wheel. I go into object mode and select the body. Here I introduce another tool of this plugin called Additional Bone Rigging. We need to define the start and end location of the bone we want to create here. Well, while body object is selected, I go to Edit mode. Since the center of my steering wheel is a separate element, I can hover my mouse over it and press L to select the whole element. I select the front vertices of the steering wheel and set them as head location. Now in order to see the end part of the steering wheel, with Shift plus Z, I go into wireframe mode. From here, I select the end vertices, and by dragging with the Control key, I deselect the vertices I don't want. Now I choose them as the tail location, then return to the previous mode with Shift plus Z. From here, I select the rig I created, which is the armature, and set the parent bone for my steering wheel to be the body. I also name this bone Steering B. Now, we need to select the parts of the steering wheel that we want to be weighted with this bone. My steering wheel is made up of several elements, so if I hover over any element and press L, all of them are selected. Now I can click on Add Bone. To test it, I go to the Object mode, and by selecting the rig, I go to the Pose mode. Now I select the bone for the steering wheel. To ensure proper rotation, I set the rotation mode to local and rotate. It's great, our rig is complete. Now I want to show you how to create a crash effect for the car by creating morph target. If you don't need this part, you can skip to the export section. I will explain two methods for morph targets, so that if you are familiar with Blender, you can edit your model here, and if not, you can edit your model in another software, bring it here, and use it as a morph target. The first method, as I mentioned, is for those who know Blender. To do this, I go to the Object mode, and by selecting the car, I go to the Data section. The Shape Keys section is the part we create our morph targets. By clicking on plus, I create my base mode that should not change, and by clicking on plus again, I create my first morph target mode and rename it and call it Front Crash. Now when my morph target is selected, I go into edit mode and try to model the front of the car for a situation where, for instance, the car has crashed from the front. This is just an example. As you can see, I am not skilled in Blender. After you have made your changes on your model, correctly of course, not like me, go to Object mode, and by changing the morph target value, you will see that the morph target is working. Okay, I delete this morph target to explain the next method. From File, Import, FBX, I import the FBX of the model I want and move it next to my car. This model is exactly the model of my car. I just edited it in another software. The important thing is that in the changes you make, be careful that the number of vortexes doesn't change. As many morph targets you have, you can add in this way and place them next to your car. Now, in order to assign these morph targets as the morph target of the main machine, follow this method. First, select your morph targets and finally select your main model. As you can see, the main model turns orange. Now again from Data and Shape Keys section, click on this arrow and click on Join as Shapes. I change its name to Front Crash and test it. You can see that it works. Now you can safely delete the next car. Now I will tell you about the export settings. When you are in object mode, press the A button to select all the objects. Go from File to Export and FBX. Give a name to your file and activate selected objects. Choose Armature, Mesh, and other types by holding down Shift. I set forward to X forward and up to Z up. From the Armature section, I turn off Add Leaf Bone. I also turn off Bake Animation and export my file. Our work in Blender is done. Let's go to Unreal. It's better that in your project, you create a folder for your car so that assets don't get mixed up. Right-click inside the folder and click on Import. First, I will import our simple rig. Be careful in order to avoid errors. From the File Type section, select FBX Skeletal Mesh Mode, and then select the file and finally click on Open. Remember that in the Settings section and the Mesh section, Advanced, click on Import Morph Targets and then click on Import All. It may take a while, so wait. If it doesn't take long, lucky you. Now, Our simple rig has been imported as 3 assets. First, I click on the physical asset to set up the collisions. I select the root and set it to multi-convex hull mode and regenerate. Now I select 4 wheels and regenerate on sphere mode. Now save it and close. Right-click on the skeletal mesh and from the Create section, select Create Control Rig to let Unreal make our control rig. I open it to start creating our controllers. Go to the My Hierarchy tab, right-click on one of the bones, it doesn't matter which one, and from the New section, select New Control and name it Body. Similarly, I create 2 more controllers with the names Wheel Rotation and Wheel Steering. By selecting each of them and going to Shape Properties, you can change their color. The important thing is that the controllers should not be a subset of the root of our car. So we right-click on the empty space, and from the New section, we create a null. I name it Controllers, and move all my controllers here. To move each part of the car with a controller, for example, for the body of the car, this is what I do. I drag the controller on the screen, press Get Control, then place the body, which is the root in our simple rig, on the screen and press Add Offset. This way we can connect transforms together. For instance, here we want to connect the rotation of controller to the rotation of our body. Now I connect the executes together so that the blueprint flow happens. By selecting the body controller, you can test it. Since in our simple rig, the wheels are a subset of the body, they will rotate along with it. To prevent this, we need to turn off Propagate to Children, and you can see the result. Now, if you follow the simple rig pipeline, go to the Wheel Steering and Wheel Rotation Creation section. After that, check Controller Appearance Settings and go to the section for creating animation. Now let's learn some more tips about our complex rig. Using the method I mentioned earlier, I imported our rig. To set up collisions, follow the same process as before. That is, select the body and set it to multi-convex hull mode and regenerate. Then set the 4 wheels to sphere mode and regenerate. For doors, you can also use multi-convex hull and press regenerate. Since the steering wheel is circular, it can get collision from the sphere mode. In general, decide based on the shape of your object. I have already set the car materials. By opening the skeletal mesh, I can adjust them. I create my control rig and open it. You can see that our bones have increased and now they have their own subsections. According to what we did before, I will make our controllers, that is, controllers for body, wheel rotation, wheel steering, and 2 additional controllers compared to the previous part for right door and left door. Then I will consider 1 color for each controller. And finally, as mentioned earlier, I right-click in an empty space and create a null named controllers and make all controllers its subsets. Now, as we did in our simple rig, I bring get controller from body controller, open its transform, and from body bone, which is separate from the root in this rig, bring add offset. I open this node's transform as well. Now I connect the rotations and connect the blueprint flow. Now let's test it by selecting the body controller. You can see that the doors are connected to it and the wheels are disconnected from it. This is the reason that in this rig model, we need a separate root. Now let's create the wheel steering part. Make sure to create the wheel steering first and then the wheel rotation, because otherwise the result will be wrong. Now from the wheel steering controller, I will add its get control, and from the transform section, we open the translations. The logic of this section is that by moving the controller along y-axis, we want the wheels to turn left and right and tilt. So from the Y output, pull out a wire and search for multiply and enter 0.35, which has been tested before. Now right-click and search for from Euler, create it, open Euler section, and give the output of the multiply to Z. Because steering is only for the front wheels, I drag the bones of the front wheels on the screen and press add offset. Then I open their transforms. Now I connect the result to my rotations. Don't forget to connect the execute of the two nodes together as well. You can connect the blueprint path from the continuation of the previous node, but it's better that at the beginning of the nodes, I create a sequencer and connect the execute to it. Now you can connect its outputs to your nodes to be performed in continuation of each other. If you double-click on your wire, a node will be created which you can organize your blueprints better. Let's see the result of the steering controller too. Now, if you are following along from the complex rig part, you saw that we rigged the steering wheel. Here, I want to connect the steering wheel to the steering controller as well. For this, I copy my from Euler node and give the output multiply to the Y section. Then I get add offset from the steering bone, which is a subset of the body bone. I open its transform section and connect the result to rotation and connect the execute of the last bone of the wheels to it. Now if you look at the steering wheel from inside the car, by selecting the steering controller and changing its Y direction, not only do the wheels move, but also the steering wheel rotates. It's time for wheel rotation. You might think we want to connect the rotation of the controller to the rotation of the offsets so that by rotating the controllers, the wheels rotate as well, but this makes it difficult for the animator because he has to calculate the path and rotation value of the wheel. I have a better way. By rotating the controller, the wheels should rotate in a certain ratio permanently. I will show you the result so that you understand what I mean. For this, I first create a get control float node, and from control section, select wheel rotation control. Now I multiply the float value by 50, which has been tested before. This number is the ratio of the speed increase to the rotation of the controller. Then I multiply it by half pi and connect the result to accumulated time node, which makes the wheels have a constant rotation in proportion to the time. Now I connect this result to the Y input of from Euler node. Then I organize my nodes a bit so they don't look too cluttered. I bring the four wheels to the screen and click on Add Offset, arrange them, open their transforms, and give the result to their rotations. Don't forget to connect the execute between the nodes together. Sequencer by default has 2 pins, but you can add more pins to it. I add a pin to the sequencer and connect it to the wheel rotation section nodes. By selecting the wheel rotation controller, I can rotate them. As you can see, the problem here is that the calipers are also rotating with the wheel. To solve this problem, in each of the 4 nodes, I have to deactivate Propagate to Children. Here's the result. Now it's time for doors, which are easier than all the other parts. I create the get control of both doors, and from the bone of both doors, get the add offset. Then I organize them and open their transforms. Now I connect the rotations together and connect the execute of the 2 nodes together as well. I add a pin to the sequencer and connect it to the execute of the doors. Now by selecting the controller of each door, you can see that our doors open and close. Now I group the nodes so they don't look cluttered. I do it in this way, that select a few nodes and press the C button on your keyboard, then you can name them. For instance, For this group, I select the name Body. I'll also group other parts like wheel steering, wheel rotation, and doors. Now, for our controllers to be accessible while animating in Level Sequencer, we consider an appropriate shape and location for them. For example, for the body, from the Shape section, I select Solid 4 arrow. And from Offset, I raise its height. Make sure that you change location and scale in the Offset section, otherwise the rig itself will be disordered. I also increase its size and set it to 10. As you can see, the controller is not visible. To fix this issue, I go into Editor View and set the mode to Animation mode. Here we need to deactivate Hide Control Shapes. Now you can see that our controller is visible. I can set the value type to Rotation so that while animating, it only shows me the rotation options. Additionally, we can also set the minimum and maximum for our range of motion. For all directions, I currently consider a negative value of 3 for the minimum, and also I consider 3 for their maximum. We need to test and see if these values are suitable or not. As you can see, these numbers are not completely limiting and the wheels go inside the body. According to the current section, you can limit the numbers and change them. I set my minimum y to negative 0.5 and set x to negative 1.5. I also set the maximum x on 1.5. As you can see, it is better now. Now, I select the wheel rotation controller and set its shape on arrow to solid. I move it a little to the right and also increase its size. To change rotation, make sure to use the Shape Transform section. Otherwise, your rig's rotation itself will be disordered. Now I set its value type to Position mode, so that the wheels rotate with its movement. The performance of this controller is excellent. For wheel rotation, I also set minimum and maximum values and do the same for wheel steering. For example, selecting a shape, setting value type to Position, and adjusting minimum and maximum values. You can see the functionality of this controller. Now it's time for the doors. I place both doors on quarter circle solid mode, adjust their size, position and rotation according to the points given earlier. I also set their value type to Rotation and adjust their minimum and maximum values so that the door doesn't open too much and doesn't go inside the body, setting them between 0 to 90 and negative 90. You can choose any shape you like and any limitation you want. Now I compile and save. Okay, our controller is ready, and we have completed an important part of the work. Let's animate the car. In this stage, I want to show you how, with the help of a camera rail, easily animate your car, and using the control rig we created, add details to your animation. This is the environment I've prepared for this tutorial. I go to Add to Project section, and from the Cinematic section, create the camera rig rail. You can select its points and move them around. If one of your points is at a distance from the road surface and positioned in height, to snap the points on your road, grab them and press the End button on the keyboard. Also, with the help of Alt-Drag, you can add the points. To see the performance of the car on the rail, I place the car static mesh in the environment and make it a subset of the rail. If you take the car to its 0 point, it actually goes to its parent center, which in this case is the rail itself. I select the rig rail and enable Lock Oriented to Rail option so that the car rotates according to the track. If this option doesn't work for you correctly, you should check the car's rotation, and if it's not 0, make it 0. Now, with changing the current position on rail option, I can move the car along the rail. Now that we have learned its logic, Let's create an animation in a level sequence. Again, I create a rig rail from the Add to Project section, Cinematic and Camera Rig Rail. I try to create the points of this rig rail based on the animation we want to create on the road by Alt, dragging and using the End key on the keyboard for snapping to the road. As you can see, here I am trying to create an animation path for drift in the curve of the road. Now right-click in the content drawer and from the cinematic section, create a level sequence. I name it LS, level sequence, _ car animation, and open it. I go to my cars folder and add a copy of static mesh of the car to the level. I add the camera rig rail and my car to the sequencer. Now I click on the plus button next to the car, and from Attach section, I choose Camera Rig Rail. The car became a subset of the camera rig rail, and its position changed compared to its parent, that is the camera rig rail. If we set the position and rotation of the car to 0, it will be placed on the starting point of the track. Select the camera rig rail and enable the Lock Oriented to Rail option. From the plus section of rig rail, add Current Position on Rail to the sequence. Now by animating this option, we can make the car move on the rail. I set it to 0 in the first frame and keyframe it. In the last frame, I set it to 1. You can see that the car has been animated. If you want the car to have a constant speed throughout the entire path, you can select 2 frames, right-click, and choose the linear option. You can see the result. The advantage of this method is that you can change the direction of movement at any moment. You can see that decals from the road are falling on the car. To fix this issue, search for decals on the car and disable Receive Decals. Now, if we want to animate different parts of the car using our control rig, from the plus section of the car, we need to go to Control Rig section, and from Control Rig Classes, select our control rig and add it to the car. You can see how our control rig works. Now by using these controllers, you can animate the car. Inside our tracks, open the control rig so that you can animate its internal components. First, I animate the steering wheel based on the direction of movement. Then I add wheel rotation. Set its value to a number that you think is suitable for the speed of the car. The important thing is that in the first frame, keyframe it, so that the result is visible in the render too. To create a drift animation, you can use references. You need to move the car to where it is supposed to drift using the transform section. If there is no transform, add it from the plus section of the car. I open location and rotation and keyframe them a few seconds before the part where the car is supposed to drift. I move forward a few seconds, take the car off the path, give it rotation, adjust its timing, and look at the result. Now in a part of the road, the car needs to return to its previous state. Here I keyframe location and rotation, move a few seconds forward, set location and rotation to 0 so that the car returns to the path. A few frames back, I rotate the car in the opposite direction to make it look a little more natural. It is much better. I work a bit on animating steering to match the drift mode we added. Now I go to the body controller. In the drift, I want it to lean slightly outward. I keyframe its frames to see the result. I also make the last frames of the animation for the body and steering. Now we need to place cameras. I click on camera to create a camera. I select it and in the setting I set its dimensions to DLSR. I want my first camera to be next to the car before drifting as if it were attached to the car. For this reason, via attach from the plus section of the camera, I attach it to the root bone. Now I move the camera and take it to the side of the car. The result didn't turn out bad, we'll improve it later. Let's create the second camera. I click on camera to create it, move it into place, and place it in the drift section. It looks good here. I keyframe it so that if I make a mistake and it is moved, it will go back to its place. Now I create my third camera and place it behind the car so that we can see after drift from this angle. To stabilize its position, I keyframe it as well. Now, through the camera cut section, I set at which second the camera changes. I click on the camera icon to go to camera cuts. Go to a frame where I want to switch to the second camera, and from the plus, I select the second camera. Similarly, I go to the switch to camera 3 section, and from the plus, I select camera 3. Here is the result. I want to add some shake to my first camera to make it more natural. To do so, I right-click on the content drawer next to the level sequence and click on Blueprint. I open all classes and search for camera shake and create a camera shake base. I open it once, close it and open it again. It's a bit strange, but the first time it opens in a different way and you have to open it again. Set it to the Perlin noise mode, compile, save it, and add its window to the top tabs so that we can make the changes we want inside it. Inside Sequencer, click on the plus next to the first camera, and from the camera shake section, select the camera shake we created. Open the camera details so we can see the inside components. As you can see, its timing is short. We go to its settings, and from the timing section, I set the duration to 0 to make its timing infinite. Save it. Now I can manually adjust its timing. The shake intensity is low. I go to the location section of the settings, and for the amplitude section, which means once every few seconds, I put the number 0.2, and for the frequency, which means number, I put the number 4. You can see the result. I go to the setting, and in the XY sections, I put the displacement value in each direction in the amplitude sections to number 2 for each. Let's see the final result. Now let's move on to the next point. In this part, we want to create the suspension mode in the wheels, meaning that the car's wheels automatically react to obstacles on the ground. You can see that in the example here, the wheels pass through the obstacles. Let's fix that. Open the control rig and go to my blueprint section. The logic of our work is that I want to get the change of offset of the obstacles on the ground from the car body and apply it to the wheels. For each of the 4 wheels, I create a variable of type float. With the name z_target_fr, take 3 copies and rename it for each wheel. We are going to store the difference in the distance between the obstacles on the ground and the body here. Now I create 4 more variables and name them z_offset_fr. I make 3 copies and rename them for each wheel. These variables represent the final height of our wheels obtained from the 4 variables above. Now I create a function called wheelTrace function. Here, using each wheel, we are going to detect obstacles on the ground and send their height offset value outwards. So I consider an input variable for it which represents our wheel bone, named wheel and of rig element key type. Our output is our height offset value, named z_target and of float type. To detect objects on the ground using our wheels, we use the sphere trace by object type node. We want to create our start point and end point. I add 2 types to the object type. In this section, we tell this node what types to identify. I set world static and world dynamic. For radius, I need to enter the diameter of the wheels, which is different for each car. I created an empty level. I bring the car into the level. From the right view, by the use of middle mouse drag, you can get the diameter of the wheel. The diameter of this wheel is 76 centimeter, so I enter that. Let's determine the start and the end. I create a getTransform node and connect the wheel that we will get from the car wheels to the item so that I have their information here. I go to my rig section, drag root bone onto the page, and click on Get Bone. Now I open their transforms. From Transform, search for Add and select the one that is in the Math section. Create the subtract from the bottom transform and open the A and B parts of both nodes and open the translations of Add and Subtract. Because X and Y of the wheel do not play any roles in our calculations, I enter X and Y of the wheel into Add and Subtract in section A, and to avoid any changes in it, I do not put anything in section B. Now I will give Z from root to section A of both nodes, and for section B, I put number 30, put this number as a test, and then come back and change it after seeing the result. This number moves the wheels inward or outward from the body, and it varies based on the size of the cars. I give Add to start and Subtract to end. From hit location, I send the value of Z to the output. Now I go to the Forward Solve tab. Now we want to use the function we created to change the height of the wheels. From my blueprint, I bring my function to the page, open the wheel section that we created, and set its type to bone. In the name section, I select one of the wheel bones, for instance, front right. I bring the variable z_offset_target_fr to the page and press set, because we are going to adjust its value. I give the output of my function to the variable z_offset_target_fr and connect the executes. We do this for our 4 wheels. That is, set up the function on one of the wheel bones and bring the offset target variable of that wheel and give it the output of the function. Here we store the offset of the obstacles on the ground in our own variables. Also connect the executes, and from sequence, connect the pin to these nodes. Now we need to convert this offset to the height we need for the wheels. Get the variable z_offset_target_fr on the page and create the alpha interp node. Connect the variable to value. Now set the variable z_offset_fr on the page and give it the value of result. Set both of these numbers to 20 so that we have a suitable rate of speed change on the wheel's movement. Also, tick interp result so that we can have a smooth transition. Do these steps for all 4 wheels and connect the execute ports. Now that we have the displacement value for each wheel, we need to apply it to each wheel's transform. The wheel rotation section is where these changes are placed. I open transforms and connect the z offset variables related to each wheel to their own z values. If your wheels have calipers, this height change should be applied to them as well. So I take a copy of my nodes, and in the name section of each, I select the bones related to calipers. For instance, instead of FR wheel bone, select FRC wheel. I also copy my variables and assign them to those bones. Don't forget to group the new nodes. Currently, this change is applied in the sequencer, but it is not visible in render. To solve this issue, next to the assets of my car, I create a blueprint of actor type with the name BP_car. From Add section, I create a skeletal mesh, and under its subset, I create a control rig. For skeletal mesh, I select car. And for our control rig, I select the rig we created. I compile and save, and go down in the control rig settings and click on the plus of on pre-initialize. I create the mapped skeletal mesh node, connect component to target, and connect skeletal mesh to skeletal mesh component. Compile and save. Remember that from now on, if you make a change in your control rig, you should open its blueprint and compile and save it once to see the result. I go back to the level and place the car's blueprint inside the level. I bring it to the sequencer. Now I delete my old skeletal mesh and give the car's blueprint from attached section to the camera rig rail. I set its coordinates to 0 and give a number to wheel rotation and animate it. In the result, you can see that the wheels move inward a bit too much. So I go to our control rig, and inside the function we created, I set the add number to 20. I compile and save it, and as I said, to see the effect of this change, we need to compile and save the car's blueprint as well. It's better now. By the way, don't forget that in order to get a good result, it's important that your car and obstacles on the ground have correct collisions. Now with the help of body controller, you can animate the body manually, but I made this automatic as well, let me teach you. I open the control rig. As you can see, we already have information about the upward and downward movement of the wheels, and based on this information, we want to create a body suspension system. Let's examine what happens if I raise the front right part of the car using the body controller. If you look at the current part, you will see that X is negative and Y is positive. Now let's check the front and left. X and Y are positive. You can check other directions as well. But from my experience, we need to consider these in reverse. In order for you to remember them, I've made a picture that you can take a screenshot of. We will use this as reference. The best place to make these calculations is in the body controllers section because we are dealing with body rotation. I create a function called body suspension. For this function, I create an output named rotation of type vector. And we need two inputs, one named intensity of type float to control the suspension intensity from outside of the function, and another one named smooth level of type integer, because the node that uses this number accepts an integer. This is used to control the smoothness of car's movement. Now let's build the main function using z offset variables because they have height information of all four corners. First, I bring z offset fr and get it. Then, I create two multiply for it. The first multiply is for simulating x, and the second one is for y. According to the image, x is positive in front right, and y is negative. So I set x to 1 and y to -1. So our height number has the right conditions to rotate the body in the direction we want. Now I create a make vector and assign the first one to x and the second one to y. I add 3 more variables to the page to create the same conditions for them. I take a copy of the nodes we created and place them in front of each variable and connect them. Now for each direction according to the image, I make x and y positive or negative. For example, for rear right, both x and y are positive, so I set both multiply numbers to +1. I do the same for the other two sides according to the picture. Now I add them all together. I pull a wire out of the first one and search for add and create the one in that is in the math section. I assign the second one to B and add 2 more pins for 2 other directions and add them as well. Now for controlling the suspension intensity, I multiply the output of add. I open part B and assign the intensity we previously created to x and y. Now I give the output of the work to rotation. Now I go back to the forward solve section. I place the body suspension function between sequencer and body offset and connect from sequencer to function and from function to offset transform. I create a from Euler node, give the rotation to it, and connect its output to body rotation. I set intensity on 1 as an initial test. Then I compile and save, and as I said before, I compile and save the blueprint as well. Look at the result. The intensity is very high. I set the intensity to 0.2, and after compiling and saving, I look at the result again. It got better, but it happens very fast and sharp, and it is not like a suspension. I go to the control rig and open the function. I need to add a node between the variables and multiplies. I right-click and search for average, and click on Kalman filter. As soon as you assign the output variable to its value, it will turn into average over time node. Now I give the output of this node to the multiplies. Now copy it and do the same for 3 other variables. Then I connect the smooth level, which is our input, to the buffer sizes of each node. Inside the forward solve, I set the smooth level to 20. We will see the result after compiling and saving. It's great, but the problem is that we no longer have control over our body controller. To fix this, I go to our control rig. From the output of my control node, I draw a wire, search to Euler, and create it. I create a space and disconnect the top from Euler. Now I add the function rotation to the controller rotation and give its output to from Euler. I compile, save, and test it. You can see that the suspension is also working and our body controller is functioning as well. In this case, even if somewhere the wheel and body go inside each other, you can fix it with the controller. Now I want to explain how to use morph targets to create an accident animation. I animated a scene where you can see that the front of the car needs to bend inward using morph targets, and the back of the car behaves strangely due to suspension, which needs to be fixed. As you know, I created my morph target in Blender and named it front crash. You can see that front crash is visible inside of my static mesh, and it can be changed. You need to check your morph target inside your control rig in the curve container section too. If during import you had ticked import morph targets, but there is still nothing here, you can right click here and from the import section select your car to add its morph targets. If there is still no change, you can go to your static mesh and click on re-import base mesh to bring in the morph targets. After your last nodes, create the set curve value node, set the curve value to front crash, and connect execute to it. I go to my hierarchy section, create a controller named front crash, make it a subset of my controller's null, set its value type to float mode, drag it and get it, and give the float value to value. To fix suspension, I go to the wheel trace function and delete the last connection. I create a multiply and connect Z to it. For part B, I create a controller in my hierarchy section and name it suspension intensity. Put it in controller's null, set it as a float type, bring it on the page, connect float to multiply, and finally connect result to output. I compile and save and return to the sequence. In the controller section, you can see front crash and suspension intensity, which have a default value of 0, meaning they are inactive. We can activate them whenever we want. Now I animate front crash to create the effect. The result turned out very good. In this section, I want to teach you how to use the control rig system that I created. If you look at the file you have, it has a content folder. Open it and copy the car_solely animation folder. Go to your own project, right-click on content and select Open in Explorer, then paste the file here. You can see that it has been added to the project. Pay attention that if you want to use my control rig, your bone naming must be like mine, as you can see in the image here. Create a folder for your own car and import your car into it. If you have morph targets, proceed from the mesh section, advance, import morph targets, then click on import all. I create a folder for materials to keep things organized. Right click on your static mesh and from the create section, create a control rig. Open it and also open my control rig. Now it's time to copy. Just follow these steps. First, from my hierarchy section, select all controllers and their groups except for front crash and copy them. Paste them into your own control rig. Then go to my blueprint section in my control rig and one by one, copy the variable to your own control rig. Unfortunately, they cannot all be selected together. Now select all nodes except for forward solve. Copy them and paste them into your control rig. Confirm the messages so that they are pasted. Move forward solve to before the sequence and connect it to execute. You can delete the last two nodes that were for morph targets. In the editor, go to the right view and use the middle mouse drag to get the diameter of the car wheel. Go back to the controller and go to the wheel trace function. Enter your own wheel diameter in the reduce section. Compile and save. From the car solely animation folder, copy BP car to your own folder and open it. Click on the static mesh, and from the skeletal mesh asset, set it on your car. Select the control rig, and from the control rig classes section, set it to your own control rig. Compile and save it. Then add your car's blueprint to the scene. Now if you create a sequence level and add the car to it, you will see all the controllers. Thank you for being with me throughout this course. I hope I have taught you something useful. Don't miss our other courses. Goodbye.